All right, coming to you live here from the 807 studios. This is for well, I'll just put the opening thing on here. Anyway, it's a Tuesday, September the 22nd. So we'll talk about what's been going on. Let me share the screen. All right. So we are recording. Announcements here. I don't go over to so many announcements on these wrap-up videos, but I guess I should. So no night Zooms. Whenever we're remote or virtual like this, I'm doing a Zoom every day, plus a wrap-up video, 2 wrap-up videos. So I think that's enough. That's, you know, if you wanted to, you can get 7 videos out of it. So that should be enough for anybody. So no night Zooms when we are all remote. And always a reminder to always go back to the home page and I should keep this up. I try and keep this up, you know, a couple times a day, keep it current. So that's what's happening this, and also it tells you what happened last week, what's happened this week, and what I think what's going to happen next week, but we still don't know the daggone schedule. Here's a key to 1.4, and I've posted this now so I can blow it up. But this is the how I want these to look. And I've been really pleased with the students that have turned this in. And out of 80, I think I'm down to 81 students now from 83, but 81 students, 52, something like that, have turned it in, have graded it. So those that haven't, now remember you're losing 5% a day, which equates to a point a day for being late. But those that have turned it in are doing a really good job. Some of the things I'm taking off for, and I am not looking, trust me, I am not looking at details on this. Now I will look at details on tests. That's why I post the key. I want you to check all the details. I'm looking for like big mistakes. Now a big mistake might be to put, like if you put, say, an I roof there or a J roof there, that's wrong. So distance is a scalar. It's not a vector. So you wouldn't put a unit vector with a scalar. If you did, you turn it into a vector, but distance is considered to be a scalar. And you do need to have, though, the I roofs and J roofs here. And so this is the main mistake students are making. Some of your graphs are off, but you can look at those graphs on the key to make sure that you're agreeing with me. Get down here to these, and as long as you had an equation with some I's and J's, you just said okay. I'm talking about these down. Oops, I'm talking about these down here. This is where you had the graph and you had to figure it out and then write the equation. So if you can do this worksheet really well, that'll be some good points. You'll find this 2 similar problems on the take-home test. At least this is the part A of the take-home test. Part B is coming next week. All right. On the Facebook group, you want to go, like if you go on Facebook, if you go, just all you do is look at the discussion, that is like looking at new on Reddit. I mean, it's a mess. If you ever do that, it's just whatever pops up. So that's just whatever gets attached to the Facebook group chronologically, or reverse chronologically. So from the newest first, but that's a mess. There's no organization to it. So you want to look at units. So go to units, and that's probably where you'll spend 90% of your time, maybe 100% of your time on the Facebook group will be in the unit section, because that is laid out like you would, like it has sheet 1.1, sheet 1.2, 1.3, and those are in reverse order with the newest sheet first. And then it also, the unit 1 is all the sheets, unit 2 is all the take-home tests. So you'll have take-home tests in there. And then if you want to speed up things, if you make a comment, the best way to do it is to write in your comment somewhere, put this, or this. This stands for question for Askey, or you can just write Askey, or you can write THT. All those will alert me that you have a question. And when I first go to my Facebook, I first open it up, which I do a lot because mainly because of you guys, or I'm arguing politics with some wag, but mainly it's you guys. So it'll tell me right there you have an alert. Someone asked you a question. As far as take-home test 1A, remember I've talked about this already. It's on the cover of the Canvas. It's on the cover of the Facebook group. But just to tell you again that if you haven't printed it off yet, it's off the PDFs. On the PDFs of, now it's module 2. I moved that one module that no one ever looks at. I moved that down to the bottom. So now this is module 2. You can print off the PDF. But if you don't have a printer, then you can just come by my house on 812 Carriage Lane, which is, there are those Victorian homes just north of Whittier. And you come up to my porch, and there's a box there that has about 25 of them in there. If you go to the box and it's empty, then just ring the doorbell. I'll rustle up a couple more. But all right, so that's there for you. If you either don't want to print it off or you can't print it off. But this is due Friday night, so don't wait till Friday afternoon. I know some of you will, but if you wait till Friday afternoon, you're going to have kind of a rough Friday evening. I'm warning you. You got to get the whole thing done by Friday at midnight. You can do it, but it kind of blows your Friday night. All right. Of course, what else are you going to do? Heck, we're all quarantined. Now, on that test, and I may have already gone over this, but this is what I'm thinking right now, that this is how we're going to do it. So we PDF my house, work on the front and back. I would try and have the front done by Thursday. If you can use any resource you need. Now you submit a pic of the front and a pic of the back by Friday at midnight. Do them both at the same time, please. Canvas doesn't handle that well. When you turn in, like say you finish the front and you're happy with it, you take a picture, you turn it in, and then later I'm going to see that as half credit. So then it's all messed up on the grades. Then you turn to the next one, and then I give you another half credit. Well, Canvas takes whatever the higher grade is. So turn the whole assignment in at once. Okay. Not in pieces. I'll award you up to 75 points for good effort. I'm assuming that you are checking with each other. You're going to the Facebook group. I'll put answers on things if it's a lot of work to be shown, but a lot of times an answer doesn't do you much good unless it's a one-step problem. If it's like a unit analysis, like gold standard, and it's a 10-step problem and you have the answer, you're only going to get 2 out of 20 points if all you do is write down the answer. So most of the points come in the work. And I'll post the key eventually. Now it'll get posted on September 28th on Facebook, September 29th on Canvas. I'm trying to give you more incentive to go to Facebook. That's where all the explanation is. So go there and check the key. We used to do a red day where the kids graded in class and we all went over it, but we can't really do that now. So you're kind of forced to go there on your own, but definitely do that. You don't want to be studying the wrong stuff for the test. Really, all you got to do on a test is study the take-home tests. You don't need to study all the worksheets. Just study the take-home tests, and that's where all the points are. All right. So there's the problems, and there's the problems in the back. Now, this is the first sheet. You'll get another sheet front and back next week sometime, probably later next week. The test, I moved the test to the actual test 1. Oh, let's do it here. I'll get it in a second. So Sophia asked this question on the Facebook group under number 2. Each one of these, each problem on the take-home test is listed, and you go over it. But she asked this question, and I got to it. I don't know, it took me a little while. Well, I guess it just took me 6 minutes, maybe. I don't know. But I got to it, and I would have got to it a little faster, though, if she had typed in either QFA, Askey, or take-home test 1A. It would have given me an alert. So do that, too. But anyway, so I answered in 4 comments. I think I finally answered her question. Now, this is test 1. As of now, it is sitting at 300 points. It won't go more than that. Last year, they were 250, but we had a lot more things we did. So I'm having to bundle all this stuff together into one test. And so to keep my points worked out, that makes it about 300. So you can see that THT, take-home test 1A, is 75 points. Take-home test 1B will be 75 points. That's going to give you 150 points. And then the in-class test is double that, and that's fairly typical in here. So that's why I got the 300. We're looking at October the 13th. I think that's a Tuesday. It was going to be October 8th, but October 8th turns out to be fall break, and I'll be down in Austin, Texas for that. So we're going to do it in class. If we're all together in a traditional schedule, we'll just take it as normal in class. Paper, pencil, you get the hour to do it. It's one side, front and back, but it'll take you bell to bell to finish it. If we're in alternate schedule, I got to figure it out, because that means one class takes it on Monday, another class takes it on Tuesday. So I don't know. That's going to be weird. We'll see. These plans, that's kind of the key word this year, is to be flexible. These plans may change. If we're all virtual, then I don't know. That's bizarre. But I may try and do it through Zoom or for each class. I don't know. That'll be probably pretty much a disaster. But we'll see. That's the plans right now. So today's physics, we're going to spend about half the time what's left on sheet 1.5. This is on the Facebook group. I strongly suggest you watch this help video. This is for the front there for this one. You could try it on your own first and then watch it. Probably don't try it on your own, because we're not. It's a medium. It's more in the hard range. So you're probably going to frustrate yourself if you try it on your own. But do watch this silent help video on it. And then there's number 1, which we did in class last week, and there's the key to it. I don't have a silent help video on it. I'll give a blow-up view of that. There's the key to which we did. I think we did this on Friday last week for group 2. Group 1, you didn't get to do this together, so you're going to just kind of rely on the key, unfortunately, and on the wrap-up video. I went over it some in the wrap-up video, kind of showed you the step-by-step. That's from Friday's wrap-up video. There's number 2, and if you were here on Friday, we went to the board on that, and I could show you a video of students, or show you some remnants of what was left over from third hour, but the students got most of it done, and we wrapped it up. This is the finished. It's not totally done. I haven't done the math yet, or the arithmetic, but there's all the unit analysis part. I didn't squeeze in a drawing. Well, that was done on my part. Okay, I didn't squeeze in a drawing. I see. So if I were to grade this on a test, yeah, I'd lose some points here. Let's say it's worth 20 points. I'd lose a couple here. I didn't put an answer, so I'd probably get a 16 out of 20 on this. Even though it never really got answered. I never answered the question, but all my work is correct. And I was a little sloppy and didn't put a drawing there. So that's kind of how I would grade that one. Now here's the big one. This is in the hard range. So you're not expected to know how to do this one until about December. Okay, but I want to give you a preview of things to come. And in college, a lot of times your professor will show you some examples in class, and they'll show you like easy examples, and you'll all leave with this false sense of security. And then you look at the homework and you freak out. Like the homework was like 10 times harder than what the professor did. Like they were trying to show you the concept and then left all the details out. So here I'm doing the opposite. I'm going to show you a hard problem, and then the homework, which is 1 and 2, is much simpler. So here we go. This is a slide on help video, and I'm going to go ahead and play it and just let it run, and I'll talk as it goes. So here's these can be very helpful. Some students like them, some students wished I would talk to them, but sometimes it's better if I don't talk. It's easier to make them for one. Well, it's hard to make them because you got to write all these notes. But anyway, so here I'm going through all the steps, and I'm showing you the symbols. I'm showing you what each one is. This is a formula that you were given. Now you draw a sketch. The sketch doesn't have to be that fancy, but you do need to have at least the symbols on there. So it's sort of your graphic organizer. So there's all the things that are happening here. What I'm given, what I'm trying to find, which is drag coefficient. So then on your symbol thoughts, that's where you figure out what equation you're going to use. Well, I already gave you the equation. So then it's just a matter of manipulating that equation. So there's the equation here that I'm going to use. So I go down and I write the equation out that I've come up with. And then I got to isolate my variable, which in this case is that capital D. And so remember this from Algebra 1, you divide out everything, or you multiply both sides to get rid of it. And so you get the D by itself. And so over here, then the next box is the isolated equation, and that's 2RA over rho AV squared. That's a rho there. And so down here, then you put all those in the, let me pause it for a second. So this is a crucial step. If you had gotten to the isolated equation up here, to this equation, and this problem's worth 30 points. It's probably, one like this on a test is probably worth 30 points on a 300-point test. So we're talking 10% of the points right here. You'd probably get, if you got up to that part, you'd probably get at least maybe a 12 or 13 out of 30. And then come down here. Now each one of these are really important. And if you got the blue, if you got these little boxes filled out, now you're looking at least a 15 out of 30. So half credit, you haven't done anything. You haven't done any kind of conversion of anything yet. All right, so what I do, I've already done this, but yesterday and Monday, we kind of went over this, and then Monday afternoon, I made this help video. So in third hour, we just watched the help video together, and they asked questions. But the 2, okay, gets put down here. The RA gets put down here. Now, what the main mistake students make is they forget to flip these. And everyone's going to do it eventually. But they're denominators. See, they're in the denominator, so they have to be flipped here. All right, we'll keep going. Now you got to write those numbers and coefficients in the actual unit analysis. So here I've done that. So the 2, okay, that's fine. 2 gets put down here. RA, I put that out of the, it's in newtons, which is a unit of force. So I put the 0.6 newtons over 1. The density of air is 0.0012 grams per cc. cc stands for cubic centimeter. It's just a fast way of writing cubic centimeter. It's kind of what doctors do. They say, well, I'm going to give you 10 cc's of this, 10, which means 10 mils of this. Or take at bedtime 25 cc's of this elixir. Okay. So stands for cubic centimeters. 1 over A. A is the surface area, and surface area is not the profile. It's not surface area. Boom, my bad. I should go back and edit that. It's the profile area. And this is something we'll get into more towards more like January, probably. So I'm not going to worry about it too much. But the area here, you just pull this out of the problem. It's 363 squared centimeters. Is how much area is exposed to the direction of motion. So don't worry about that. We flipped it, so 1 over 363 centimeters squared. And then the velocity is 37 miles an hour, but I've got to square it. So it's 37 squared, miles squared, hours squared. So keep in mind, when you square the number, you got to square the units as well. There's another place where students make a lot of mistakes. Then this squiggly line means that we are done with all the givens. And everything that follows the squiggly line is going to, over here, is going to be conversion. or what's called clever forms of one. So I think I tell you all this in the silent help video. I'll let that run. I wrote those units in a dangerous way, and I wouldn't do it. See, this is probably better. Instead of saying centimeters cubed, put centimeters dot centimeters dot centimeters, because that way you can kill these off later one at a time. When you're going through and killing units that you don't need, if I put centimeters cubed and I kill, say, 2 of them, then it's hard for me to remember which one, that there's one left. For centimeters squared, I wrote them both out. For miles squared, I put mile dot mile, hour dot hour. Okay, that's just a pro tip. It makes your life easier. So keep going here. This is about a 5-minute video. The squiggly then, like I said, it separates the givens from the conversions. Next, we go in with these clever forms of one, and our goal now is to kill all of the units because coefficients don't have units by definition. So I'm ready to go here. I put down the slots I think I'll need. It doesn't matter what order you do them in. You can kill them in any order you want. I get the low-hanging fruit usually, the easy ones. But this time I'm going to go ahead and start with, let me pause this. I'm going to start with this. This is a suitcase. Now, suitcases are units that they've come up with where other units go into. Because, in other words, they're not fundamental units. Suitcases are combinations of other units. And in 1948, they got tired of saying kilogram dot meter per second squared when we're talking about force in the metric system. They said, let's just honor Isaac Newton and call this officially a Newton. So I'm always surprised that it took that long to do that. But I mean, the metric system was developed in 1794, and Isaac Newton was doing his thing in the early 1700s. You would think, and he was already revered, you would think in the 1800s they would come up with the idea of a Newton, but no, officially it wasn't until 1948. So anyway, the point is that it's a suitcase. So if it's in chemistry and you're dealing with joules, you know, joules, a unit of energy, well, that's really a Newton meter per second. Sorry, that's a Newton meter. Joule, yeah, power, I'm thinking power. If I say watts, like it's a 100-watt bulb, and all these suitcases are named after famous scientists. So that's why we have Newtons, we have watts, named after James Watt, we have joules, named after James Joule. So all these different, you know, amperes, named after Ampere, volts, named after Volta. So all of these are named after scientists. As far as I can tell, they're all men. I just realized that. Huh. Well, whatever. So this suitcase, Newton, is a kilogram meter per second squared, and it comes from Newton's second law, which we will learn later on this semester, okay? F equals ma. I'll give you a little, you probably have heard that one, but we'll hopefully do an activity, a really detailed, takes all hour to do this activity, but hopefully, I don't have to tell you, that would suck, but anyway, so that's a suitcase. Well, I've got to get this. Suitcases are kind of hard to handle sometimes in unit analysis. So let's go back and see what I do with it. I want to first get it in this form so that I can put it into the unit analysis. Now, one thing about unit analysis, you can't have, let's keep going here, but you can't have, this is called a, okay, let me blow it up. This is a movie, but it's kind of cool. You can pause the movie and blow things up. This is called a cell, and you can't have, the rule is, here's a cell, here's a cell. You can't have a mixed unit inside a cell. I mean, I can have multiplied units, like centimeter dot centimeter dot centimeter, or Newton dot meters, I can do that. But I can't have like meters per second. You can't put fractional units inside a cell. And the reason is it's mostly housekeeping. It confuses things when you do that. So this is how I have, I'll pause it. This is how I have to handle that Newton suitcase. I have to write it like this. Newton dot second squared on bottom, kilogram dot meter on top. Okay. Let's keep going. So that was a little nasty. Don't worry about it. We'll get to it more later. Maybe in packet 2. On the test, that won't be on the test. So I'm starting to kill things now. When I get the green pen out, you know I'm starting to kill things. So I killed the Newton unit, which is nice, but so they see that killed both these Newtons here. But that's good. But yes, you open the suitcase, so now you did kill the Newtons, but out comes kilograms, meters, and seconds squared. So it's like, oh gosh, now I got to deal with all these. Well, what are you going to do? You know, so you got to kill those off one at a time. Don't try and kill everything at once. So not much you can do about it. You had to open up that suitcase. So now the bloodbath is on. I did notice something that I missed earlier, that I can go through and kill. I could have done this at the very beginning, but I can kill 2 centimeters here and 2 centimeters up there. See, that leaves one behind. So that's why if I'd written this as centimeters cubed, it would have been hard for me to indicate that to the reader that I'm killing only 2 of them. You see what I'm saying? Maybe not. All right, so now I go through and start the process. Like I say, it doesn't matter where you start it. I'm kind of lazy, so I try and start with the easy stuff, low-hanging fruit. And I notice that I can kill this gram pretty easily, grams to grams and kilograms to kilograms. So in one fell swoop, I kill off 4 units. I'm a master like that. It's like playing a game, like a video game here. So I kill off those units. And now I go to this because I say, hey, look what I can get. Look at the bang for the buck here. I got a second. Let me go ahead and get rid of that. And I can also bring in the hour. So man, you thought the kilogram to gram was good. Here I can kill off 1, 2, 3, 4, 5, 6, 7, 8 units in one move. That's how good I am. So I'll kill all those. Eventually, there's the kill color. And now as you're going along, you're saying, okay, what's left? What can I get rid of? Now I got some miles squared, mile and mile down here. I got a centimeter left over up here. I got a meter left over up here. So it looks like that's probably the first place I should go. Let's go ahead and deal with those. So I go ahead and do that and kill my, oh, I do, oops, see, here's the thing. This seems like a bad move, right? I kill my centimeters, but I didn't kill the meters. So now I still got a meter up here and a meter up here. Well, that was dumb. Askey didn't gain anything. Well, yeah, I did, because I'm trying to end up getting rid of miles. This is where you have experience, where you've done this a while. All right, like I say, this is a particularly nasty unit analysis, which you're not going to be tested over till, I say December, it's probably more like February, before you're going to have some kind of monster like this on the test. I mean, it's fun to play around with it, but I'm just using it so I can show you all these little cool techniques and these pro tips. It's got some meat on the bone, you know what I mean? Okay, so let's keep going, but don't freak out on me. Don't think you have to know this for a test yet. So now I had to think about this for a second. I said, okay, wait a minute. I'm trying to get rid of miles, but I can't just do that in one fell swoop. Let me go to feet per mile. Now, if this had been in a test, I would have written this up here. I would have written 5,280 feet in a mile. I would have put 0.305 meters in a foot if it was on a test. But this was a homework assignment. I'm assuming you can go and look it up. Okay, so feet then seems like a weird move, but I know the mile thing's coming up. So meters, I can kill off both my meters now. That's good. So I kill off 4 things at once. There it is. Now I'm going to go ahead and do feet and miles. And so I do the feet squared, the feet, mile. And now I can kill a bunch of them. I think I'm almost done here, aren't I? Finally, yeah. That's a triumphant double slash, which means you're done with all your unit crunching. I mean, that's intimidating, but you took it step by step. So now all that's left is the number crunching. And you could stop right here. Sometimes it's a good idea to stop right here and go on to the next problem. This is a 30-point problem. You're going to get 27 points already. I'd hold back maybe 10% for the number crunching, but that's worth 27 points. And so it's dumb to go on and spend forever on your calculator. There's a good chance your fat finger is going to mess it up anyway. Might as well just go on to the next problem, because you're fighting now for 3 points, where the next problem, which you're running low on time, is the next problem is worth 25 points. And so you give that problem up so you can get your 3 points here. See what I'm saying? So maybe you get it right and get a 30 out of 30, and then you left the whole daggone problem, the next problem, 25, you get a 0 out of 25. So that's just strategy on the AP exam as well, because you're going to be pressed for time on the AP physics exam next year. And in college, they write those college physics exams so you can't finish them. They're like, back when I was engineering physics, there were 21 questions in every test for some crazy reason. And the best you'd probably hope for is to get 14 of them done. First test I took, I got 11 out of 25, and I thought I'd flunked. And so I went and immediately dropped the class, because I said, I cannot have an F on my, I said, I'm not getting this stuff. I never had physics in high school. And then I found out later that the average score was a 13 out of 21. And so my score was actually a B. But by that time I'd already dropped, so. It worked out all right. I took it in college, in summer, and I did fine. All right, so keep going. Let's wrap this thing up. Now we go to the number crunching stage. And that's just, the units are taken care of now. So now I'm just carefully, sometimes I'll rewrite it with just numbers because it gets so busy up there. And then I very carefully punch all these into my calculator. And when I do, I get, dun, 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 hold on. We talked about this in the third hour. Look at my answer here. Now, didn't I violate a rule? Didn't I tell you a couple of weeks ago that when you're writing a unit, when you're writing a number in scientific notation, it should be digit, decimal, digit, right? In other words, a decimal goes after the first digit. But then down here, I didn't do that. I wrote digit, decimal, digit. Why would I do that? The answer is over here. If I write this bottom like that, then notice that all of this cancels. And so then I just might basically 1.5 divided by 15, which is right around 0.1, right? About 10%. So that's the reason why I did it that way. So remember I said that you don't always do it this way. This is proper notation, but you don't always put the decimal at the first digit because sometimes it's more convenient not to. All right, so back to this then. And my answer ends up, whoa, really? Huh, that's crazy. My answer ends up being 0.101. That green stayed there, but it's not on the movie. Okay, I get it. It's just on it's just over the screen. Got it. So 0.101. So this is a coefficient. It has no units. And you want to check these. Pretty much, it's hard to say always in physics because there's always exceptions, but most coefficients are less than 1 or between 0 and 1. So they're ratios. So anyway, all right, I spent too much time on that, but there you go. So the last few minutes here, we're going to look at 1.6. We'll spend about 10 minutes on this. This guy's going way over. I apologize. But I wanted to go over that in detail. So 1.6, this is homework. Your homework is to finish up 1.5, finish up anything you haven't done yet, and then 1.6, and then also work on take-home tests. So I guess there's up to 3 things you got to do. Finish 1.5, check out the Facebook, check out the Silent Help video, then work on 1.6, and then work on the take-home test. So here we go. And this, as of now, this is due here. It may end up being pushed back to Tuesday. Depends on what happens on Friday. So that's the earliest to be due. So let's look at 1 through 7. I mean, 1 through 7 is what we got to work on. 8 we'll work on Friday, but 1 through 7. So I asked the kids, hey, pick out one you want to do, and we'll do it together. And so somebody asked, well, how do you number 4? And we look at number 4 and say, okay, well, This is Patches the cat. And so Patches, there's a whole Patches story, which I will not get into. But Patches, if I highlight Patches here, it goes along, and then Patches comes down like this. And so the question is, what's Patches doing? Well, in the first hour, it looks like Patches isn't doing anything, just sitting there. And then from it looks like the last 20, 40, 60, is that right? About 60 minutes, the last 60 minutes or so, or 50 minutes, Patches, or 48 minutes, Patches is walking, it looks like. And then you got to figure out the slope. And so you write that out, 108 minutes. So you write that out there in sentence form, what you see Patches doing. The other one we're going to look at is, this is homework here, so I don't want to give too much away. The other one we're going to look at is number 3. That's what students asked about. So number 3 is quantitatively, which means write an equation. Describe what Joe Dynamo is doing in his Corvette. And so over here, if I highlight that line, so the question is, this is to write an equation for that line. So we're getting pretty good at this, hopefully by now. X of t equals Vt plus X naught. So just use, and someone asked this question, well, should I convert everything to meters per second? You can if you want, but it's not necessary. Just the rule of thumb is to just use, the rule of thumb here is to use the units on the graph. So the X naught is in terms of 14 kilometers, it looks like to me up here. That's my initial position. And then the velocity, now we're going to find the velocity. Well, that's my slope. And so for my slope, let me get fancy here. For my slope here, change up colors. My slope, rise over run. I have for my slope, it is this. Okay, it makes this triangle. I'm trying to make these help videos even better than what happened in the Zoom so that you'd have an incentive to go look at them. So it's this right triangle, and this is my delta T. Oops, sorry about that. This is my delta T, and this is my, sorry, I'm trying to make it look nice. This is my delta X, okay? Make this look nice up here. I'm almost done, I promise. This is my delta T. Okay, so slope, of course, is delta X, rise over run. And so it looks like I dropped 14 and I ran 40, right? I dropped 14 and ran 40. So that's 7 divided by 20, which is 0.35. So this would be 0.35, got to put the units, kilometers per minute times t, and that's x of t equals. So that's what I'm looking for. You can box it in nicely if you want. That's what I'm looking for on that one. So your homework is to do 1 through 7. Now a hint on 7. 7 should take you probably less than 1 minute. If you're spending more than a minute, you're missing the shortcut. That's all I'll say about it. This is probably, you'll see this in every classic physics problem. You see it in every textbook. I spent 20 minutes on this in college sitting, I remember from midnight, I started working on my homework as usual. And I spent a good 20 minutes messing around with this, trying to throw calculus at it and everything else. And I stupidly assumed, I said, well, let's make this assumption, which is always a bad idea. I said, let's assume that the fly spins half a second on each tire as it's turning around. Why? I was a physics rookie back then, but why would I would ever make my life harder? Don't ever throw things into a problem like that. We're trying to simplify it for a reason. So that made the problem, because the path of the fly looks something like this, right? As it's through time, as it's going back and forth. If we say time is like this, and position is like this. We do it the other way we normally do it. That's kind of what the fly's path looks like through time, until it finally gets hit. And so I was saying, okay, it took it this long, and the bicycle's going this fast. Oh my gosh, look for a shortcut. Okay, look for the shortcut. We'll talk about the shortcut on Friday, but kind of a fun problem. And then number 8, we didn't really do much on that. We talked about it, I think, in second hour, third hour. In the second hour, we didn't do much in this. But I didn't do it because we're running low on time, and also because we're going to talk about it on Friday. But look it over. It's always a good idea to look over problems. That was the secret I figured out in college. I always try to stay a chapter ahead of the professor. For one thing, professors go way too fast. So I had to, just for survival, I would stay a chapter ahead. And that way I could ask questions. I was more in tune with what was going on. I already heard the words. So in here, it would probably behoove you to look at a worksheet. Like, go ahead and look at 1 point. You have them in front of you. Go ahead and look at the back of 1.6 already. Look at 1 point, because that's kind of Friday stuff. And then maybe before next week, start looking over 1.7. Look at 1.8. Okay. Next week, we'll try and get 1.7, 1.8 done. All right. So this is 2D motion. Here is a convenient profile view. There's no work to be done here on this one, but there's a profile view of the problem. It's profile view. And then we're supposed to plot the X and the Y. So in some ways, this is a 3-dimensional plot because we have X, we have Y, and we have time. Time is considered a dimension. It's the temporal dimension, but it shows up on a graph, so it is a dimension. So you can plot, you can try to do this on your own, and then Friday we'll talk about it. Okay, now your homework. Oh, by the way, for 1.6, there are these 3 help videos. Don't worry about circular motion yet, but you can look over those. If you want to get a preview for tomorrow, you can look up, for Thursday, Friday, you can look over those first 2 2D videos. There's the back for Friday, some keys, let's go off that. And then here's the work assignment for tonight. Do any late work, finish up 1.5, finish up 1 through 7 on, or try to. Your best guess on 1.6. We're not turning that in until at earliest Sunday night. And then try and get one side done on take-home test 1A. Okay. I'm going to stop the sharing, and I hope I hit the play button. So I'm going to pause this. Go ahead and end it. See you guys. Come tomorrow. If you come tomorrow, Wednesday, we're going to spend the entire hour working on the take-home test together. So definitely show up for that. All right. See you.